Hello and welcome. In this video we are going to look at a couple of applications of electrolysis, and the two examples we're going to look at are the electrolysis of brine and the electrolysis of aluminium oxide to produce aluminium metal. Now the first one that we have here is the electrolysis of brine, and brine is basically just sodium chloride solution. I believe it has to be saturated for it to be brine, but the idea is it's sodium chloride in solution, sodium chloride being just regular salt. Now when we put sodium chloride in water and dissolve it, we have sodium ions, chloride ions, hydrogen ions and hydroxide ions that are produced, and these can actually be used to make some very useful products which we'll have a look at now. The process works a little bit like this. We have a tank that we can pump our brine or sodium chloride into, and in that tank we have two electrodes, the positive electrode and the negative electrode for our electrolysis. Separating the two halves of the tank is what we call a porous membrane. This just allows a certain amount of flow of substances but restricts other substances that might recombine in ways in which we don't want them to. So let's start off by looking at the positive electrode. The positive electrode will attract the negative ions, so we will have chloride ions that are attracted, but we also have hydroxide ions. But the way things are, it's easier to remove that electron from the chloride than it is from the hydroxide. So the electrons are removed, and what we end up with is chlorine gas. And that is a very useful product, and we'll talk about its uses in a moment. So that's what's happening at the positive electrode. At the negative electrode, we would expect the positive ions to be attracted, and in fact we have hydrogen ions and sodium ions that can be attracted to the positive electrode. Now hydrogen is much less reactive than the sodium. Sodium is much more reactive, and therefore it's the hydrogen that will be produced at the negative electrode. So what we have is electrons that are brought down, added to the hydrogen ions, and we end up with hydrogen gas. And this is H2. So at the positive electrode we produce chlorine, at the negative electrode we produce hydrogen gas. That leaves these two ions, sodium and hydroxide, which are still in the solution, and those two can actually combine to produce sodium hydroxide, NaOH, which is sodium hydroxide. Okay, so this process can be kept running, and you can happily produce these three products by this process. Now you are required to know a couple of the uses of these. So the first one here, chlorine, that's very useful because it's used to make bleach, which is good for disinfecting other types of disinfectant. It's actually used to keep tap water clean as well, and it's also used in the production of plastics, for example for something called PVC. Okay, so this is very useful. It can be used for those products there. Hydrogen is used to make margarine, and you may remember from unit C1 how hydrogen is used with unsaturated fats to produce margarine. It's also got a few other uses as well. It can be used for rocket fuel, but again it's a very useful product. The sodium hydroxide, this is actually used to make, comes out of the tank at the bottom here in solution, and this is actually used to make detergents, and detergents are cleaning products. Detergents are cleaning products, and you can imagine a whole range of them: soaps, kitchen household cleaners, that sort of thing. So three very useful products that can come from the electrolysis of sodium chloride, and you should be able to just talk about how this system works, which ions come from where, and the uses of the different products that are made. The last thing I want to look at is the electrolysis of aluminium oxide. Aluminium oxide is used to produce the metal aluminium, and it's a very useful metal because it's very strong and it's very light, so it can have a whole range of different uses. And the stages of the production go as follows. We start off with aluminium ore, and aluminium ore has a special name. It's called bauxite. And bauxite contains not only aluminium oxide but also some other impurities as well. So the first stage is to remove those impurities, and once you've done that, you're left with aluminium oxide. Now when we're dealing with other metals, for example iron oxide, we can actually react those with carbon, and the carbon will remove the oxygen from the metal. With aluminium oxide, the aluminium is more reactive than the carbon, so it will hold on tightly to that oxide. So we can't use the process of heating with carbon. What we have to do is carry out a process called electrolysis, which we know about. Right, the apparatus that we use looks a little bit like this. We have a big tank, and we don't have two electrodes poking in, one being positive and one being negative. What we have is the outside of the tank over here in the darker grey here, that's the negative electrode, and it's made of carbon. And the positive electrode actually dips into the aluminium oxide, melted aluminium oxide here, and that's also made of carbon. And the side of the tank is the negative electrode, so that's where the aluminium is going to be attracted to. But the way it works is we melt the aluminium oxide, but there's a slight problem there. Aluminium oxide melts at about 2000 degrees centigrade, and that's a very, very high temperature, and that's going to cost a lot of money and use a lot of energy in order to get it up to that temperature, and it could possibly make it unviable, not practical to make aluminium in this way. Luckily, there is another substance called cryolite, which is an ionic compound, and that has an effect of lowering the melting point. Where aluminium melts. So with cryolite, the melting point goes down to about 850 degrees centigrade. So while it's still quite high, it's much less than what it was before. So we do need to melt the aluminium oxide, as you know, because we need to have the ions able to move around in this melted substance so that we can use the electrolysis. And once we've melted it, we end up with aluminium ions, which are Al3+, and oxide ions, which are 2-. Now once we have those two types of ion, we can see that the aluminium, being positively charged, will attract to the outside of the container because it's the negative electrode, and the aluminium will then collect electrons, as we know, collect 3 in this case, and become aluminium metal, and it will be actually in a melted state. So this layer here is the aluminium which has been produced and is in a melted state because it's so hot, and it can be piped off and taken away to be processed. So that's how the aluminium is produced. Now at the positive electrode, what we have is oxygen that's produced as bubbles, and again, because of the heat, the oxygen will react with the carbon in the electrode and produce carbon dioxide, and that's a very similar process to burning. So this means that these electrodes have to be replaced regularly because they burn away. Okay, so that's an overview of the two processes. I think this is the last video for the whole of the chemistry course, which I'm very pleased about finishing. Hope you enjoyed, and I'll see you again soon.